Hello everyone and welcome to your Chem 113 review on the work energy theorem. My name is Jason and I work for the ASU Tutoring Center. Now, let me just state for you what the work energy theorem is. So the work energy theorem says, in a closed system, the total change in energy equals the work done on or by the system, as well as the heat put into or released from the system. So heat added or removed from the system. So total energy change is both the work done on the system as well as the heat that is added or removed to the system. So how we'd write that is delta E, so change, that's what the delta means, it means change. Change in energy is Q plus W, where Q represents the heat either added or removed, and W represents the work either done on or done by the system, okay? First of all, what do we mean by a closed system? A closed system means there is no mass transfer. So energy can still be transferred in and out of the system, but no mass can be transferred in and out of the system. So think about it as like, you have to pretty much close the system off so you don't get any extra sort of molecules coming in or out, okay? You can't have extra oxygen or hydrogen, gas molecules coming into the system or out of the system. It's closed off. So the molecules that are within it are the only molecules within it, and those are the only ones that stay, okay? Okay, so let's try to see this in action with what we have here. We are told a couple things. We're told the system loses 1150 joules of heat. Joules is just the energy system is the units for heat or energy. And then we're also told that the expanding gas does 480 joules of work on the system. Okay, so let's break it down. So let's look at heat first. We lose 1150 joules of heat. So whenever you lose heat, that's a negative sign. Whenever you gain heat, that's a positive sign. So in this case, our heat, Q, equals negative 1150 joules. Okay, because it's 1150 joules and we're losing it, so it's negative. Okay, and now let's look at work being done on the system. So we have 480 joules of work that the system, the expanding gas system, is doing on the surroundings. So this work is being done by the system on the surroundings. So if it's by system, that's negative. Because the system is pushing this work out into its environment. So overall, it's losing that work, right? It's pushing it out to the rest of the environment. But if work is being done on the system from the environment, that's positive. So the environment is putting work into the system is gaining energy. Okay, so that's why it's positive, because the system is gaining energy. Similar idea to up here with the heat, right? If you're losing heat, you're losing energy, so that's negative. You're gaining heat, you're gaining energy, so that's positive. If you're doing work by the system on the surroundings, the system is losing work energy. But if the surroundings are doing work on the system is gaining work energy. So in this case, our system is doing work on the surroundings. So that's going to be a negative. And the work being done is 480 joules. So work equals negative 480 joules. So overall, the change in energy would equal negative 1150 joules minus 480 joules, which if we combine those is negative 1630 joules. That is the total change in energy for the system. So overall, the system is losing energy because it has that negative sign out front. And the amount of energy it's losing is 1,630 joules. Okay, that is the work energy theorem. We'll be expanding upon this in the upcoming videos as we talk more about thermochemistry. Wonderful. Well, thank you all for watching. As I mentioned, I work for the tutoring centers at ASU. If you want more information about the free tutoring services available on all 4 major ASU campuses and online, please check out tutoring.asu.edu/content/tutor-search. Here you'll be able to find a tutor on your specific campus or online that can help with your specific class. Thank you very much for watching, and I hope you have a wonderful day.